You know, the James Webb Space Telescope's images are absolutely breathtaking. But believe it or not, some of its biggest discoveries aren't in the pictures at all. We're about to go on a deep dive to see how it found cosmic ghosts from the dawn of time that were hiding right in our own cosmic backyard. So let's ask the big question. How do you even begin to understand what a galaxy was like 13 billion years ago just from a faint speck of light? Well, the secret isn't in a photograph. It's actually hidden inside the light itself.
To figure this out, we have to travel back in time. And I mean way back, to the very first chapter in the story of our universe, the cosmic dawn.
Okay, so picture this. A universe filled with a thick, dark fog of hydrogen gas. This whole era, which we call the Epoch of reionization, is when the very first stars and galaxies blinked on and started burning away that fog, lighting up the cosmos for the first time. For decades, this whole period has been pretty much a total mystery.
But now, thanks to JWST, we are peering directly into that time. The way astronomers do this is by measuring something called redshift, and it's actually pretty simple. The higher the redshift number, the further back in time we're looking. So, a redshift of 8.5, that's just a staggering 13 billion years into the past. We're looking at the universe as a toddler.
So how on earth does JWST manage to pull this off? Well, it turns out it has a secret weapon, one that goes way beyond that giant golden mirror.
The technique is called spectroscopy. And here's the deal. Instead of just taking a picture, JWST can catch the super faint light from a distant galaxy and spread it all out into a rainbow, kind of like a prism does. And hidden inside that rainbow is a secret code, a cosmic barcode, if you will, that tells you exactly what that galaxy is made of.
All right, I know what you're thinking. This doesn't look like one of those beautiful Webb images, does it? It's just a bunch of bright spots on a line. But trust me, what you're looking at here is one of the most important pieces of data ever collected. This right here is that cosmic barcode, the chemical fingerprint of a galaxy from the dawn of time itself.
So great, we have the fingerprint. Now, how do scientists actually read it? What kind of secrets can this cosmic code possibly reveal?
You see, each one of those bright spikes you saw is what's called an emission line. And here's the magical part. Every chemical element, when it gets heated up, gives off light at a very, very specific color. So each one of those lines is a direct signature of a specific element. And in these ancient galaxies, JWST found the telltale signs of oxygen, neon, and hydrogen.
But it wasn't just about which elements were there. It was also about how much there was. So the most distant galaxy they looked at had a chemical richness, or what astronomers call metallicity, of only about 5% of our Sun. Now that is the clear chemical signature of something incredibly young, incredibly pristine, made from the raw stuff of the early universe.
And the specific types of lines tell a story too. They show that the galaxy is in a state of what's called high excitation, which is really just a fancy way of saying it's absolutely buzzing with energy, getting blasted by intense, high-energy light from brand new, massive, and unbelievably hot stars.
So, the science team is analyzing these barcodes. They're decoding the chemical makeup, they're starting to understand the conditions, and that's when they stumbled upon something they absolutely did not expect.
What JWST found was that these ancient galaxies were low in heavy elements and just blazing with high-energy light. And that's when the scientists had this aha moment. They realized that this exact same chemical fingerprint, it perfectly matched a rare type of small galaxy found right here in our modern universe.
It's incredible. They found cosmic doppelgangers, basically identical twins, separated by 13 billion years of cosmic history, but sharing the exact same chemical DNA. I mean, what an astonishing revelation.
Now this is so much more than just a cool coincidence. Finding these local lookalikes, these local analogs, is a revolutionary breakthrough. It completely changes how we can study the early universe. So here's why this matters so much. The problem is obvious, right? We can't build a time machine and go back 13 billion years. Studying those ancient galaxies directly is unbelievably hard. They're just so faint and far away. But now we have a solution. We can study their nearby twins with every telescope we have in mind-blowing detail. These local galaxies have effectively become living fossils, living laboratories, giving us a direct window into the past.
Let's just ground this in the actual data for a second.
This table here shows the properties for a galaxy they called 04590. You can see its insane redshift number, putting it deep in that epoch of reionization. And there it is, an oxygen abundance of just 5% of our sun's. This is the actual data point that made scientists start looking for its twin.
You know, the scientists who made the discovery put it perfectly in their paper. They said the properties of these early galaxies resemble those of relatively rare local analogs. It's a very quiet scientific sentence, but it represents a gigantic leap forward in our ability to study our own cosmic history.
And that really leaves us with a fascinating final thought. We'd been looking up at the sky for centuries, and these cosmic twins were hiding right under our noses the whole time. It really makes you wonder, doesn't it? What other huge, profound secrets about the universe are still out there, hiding in plain sight, just waiting for the right tool and the right pair of eyes to finally see them?